Hello, welcome back to today's episode. Today I'm going to show you an integration for biometrics that I did using the Rust programming language. To start us off, let me take you to the official Rust web page. So this is Rust's web page. You can see that from this web page you can gather that Rust is a language that empowers everyone to build reliable and efficient software. What do they say about Rust? There's something they say about performance, reliability, and productivity. So today I am going to do an integration for biometrics fingerprint capture using the Rust programming language. Let us get started. First things first, I'm going to minimize this web browser. I want to show you the version of Rust that I am running. To do that, I'm going to open the CMD, that is the command prompt, and then we check the version of Rust, and then I also show you the toolchain that I am using, and then I will also show you the other toolchains that I have installed, and I will explain why I am using a particular toolchain and not the other toolchains that I have already installed. Now let me open the command prompt. I am typing CMD so that we can open the command prompt. Now I will also show you the 12 steps that I used to capture fingerprint using the ZKTeco Type 4500 fingerprint scanner in my Rust application. Let me show you the Rust version that I am using, the toolchain, and the installed toolchains. The installed toolchains that I have installed, and the particular toolchain that I am using, and then I will also explain to you why I am using that particular toolchain. To get the Rust version, I will type Rust C space -- version. What did they type here? I will type Rust C space -- version. Then I press enter. So this is the version of Rust that I am using as of this time of making this application demo. Today is on the 15th of, is it 15th surely? Today is the what year? Today is the 16th of April year 2025. So as of this time of making this Rust biometric application demo, the Rust version that I had installed in my computer is version, what am I doing? Is 1.86.0. Okay, now let me show you the toolchains that I have installed in my computer. There is this text document that I created. I wanted to be able to access some of these items. I just wanted some of these items to be within reach, and I decided to put them in this txt file here. So this is the toolchain that I ended up working with. And then in number 2, That is how I targeted it out of the other tool chains that I have. Then in 3, I show you the tool chains that I have installed in my computer. I am going to select this bit here, and then I run it on the command prompt. I press enter. As you can see, there are 3 tool chains. There is this one for 32-bit, the GNU one. Then there's this Microsoft toolchain for 32-bit, and then there's the default one, the x86-64, the one that comes by default when you install Rust. The one that I am using for this integration is this particular one here, and the reason why I'm using the Microsoft one is because I am using ZKTeco's Fingerprint API DLL, that is the dynamic linked library, to be able to do this Rust biometric fingerprint integration. Okay, to make things clearer, when I will be building the application, I will be using this toolchain here, and when I'll be running the Rust biometric application, I'll be using this toolchain here. I could repeat that again. When I will be building the Rust biometric application, I will be using this Microsoft toolchain here, the highlighted one. When I will be running the Rust biometric fingerprint application, I will be using this toolchain here, the 32-bit one, the one for Microsoft. Reason being that for you to be able to call functions inside Rust from a DLL, that is from a dynamic linked library, you need a Microsoft toolchain. Now you could ask, why not use the x86-64 and the default one? The reason is because the DLL, the dynamic linked library that is provided by ZKTeco Fingerprint API, is a 32-bit library. It is a 32-bit dynamic linked library. So in order for you to be able to use it on Rust and create a function pointers to call the functions in the dynamic linked library, you need a 32-bit toolchain that you can use with your Rust application, and that is why I am using this toolchain here. That is the 32-bit Microsoft toolchain for Windows. Let's move on to I need to show you what else do I need to show you? At least I've been able to show you the version of Rust that I am using, and I've been able to show you the toolchains that I installed in my computer, and then I've also shown you this is the particular toolchain that my application will be using for building the Rust biometric application, and also for running the Rust biometric fingerprint application. Let me minimize this. Let me minimize the command prompt. Now, when we will be building the application, we'll be using this command here, the cargo build, and then we target this toolchain here, the same toolchain that I was showing you, this one here. Let me minimize it again. Now, when we will be running the Rust biometric application, we will be using this command here, cargo run, and then we target this toolchain here. the one that I was showing you, this one. All right, now let me take you to the project itself. I need to minimize this. I also need to minimize this, and then open the folder where my project is running from. This is the folder where I created the Rust biometric application. Now, to be able to run the application, I'm going to copy this project folder path. I just do copy, then I minimize this. But just before I minimize this folder window, when I successfully do a fingerprint capture, you are going to see a PNG image file here that is named Fingerprint ZKTeco 4500.png. Right now we don't have that file here. It will be created when we present the fingerprint on the biometric on the ZKTeco biometric fingerprint scanner. So as for now, I am just copying this path here so that I can run it on I can change directory to that path from the command prompt. Do not forget that we don't have any image file here because we have not yet captured any fingerprint image. But once we get to capture fingerprint image from our Rust biometric application, we are going to see the fingerprint image file created here. Okay, let me minimize this, and then I open the command prompt. I am going to do cd, then I change to that directory, the one that I copied, then I press enter. Now to go to this path, I will need to type E because this is the E directory, I mean the E, what do I call it, the E partition, yeah. Then I press enter, and now we are in the path where my Rust application is. So this is the main folder here, this is the main folder, and then inside this folder is where I've created the Rust application that I am going to show you in this demo. Now to open the application, okay, there is a plane that is flying overhead. Let me allow it some seconds for the noise to subside, then we continue. Let us continue now. I was saying the Rust application that I developed it on the Visual Studio Code IDE. I need to show you the Rust biometric application from the Visual Studio Code IDE. To do that, I will go to search here, and then I type Visual Studio. I don't even to type it, here it is. So I'm just going to click Visual Studio Code so that we open it. So here is the Visual Studio Code IDE and the Rust biometric application code that I implemented for doing the integration for fingerprint capture using the ZKTeco type 4500 fingerprint scanner. I used some 12 steps to be able to capture the fingerprint image, then to display it, and also extract the fingerprint template from it, and also display it on the command prompt. I will show you how I was able to achieve that. But before we even continue, I need to briefly take you through the code. Then we will come back later so that I can show you how each and every one of the steps, what each and every one of the steps does in this code. Okay. So here is the code. This is the main function. I just did everything in the main function. So there's the code. There's the code. There's the code. There's the code. I commented out this bit. This is for getting the DPI, that is the dots per pixel in an inch. That is for the image resolution. I did not need it for this demo, so I just commented it out. So as you can see, it is just a short piece of code. It is not a long piece of code. And then it is actually how many lines? Just 341 lines. Okay, let me just scroll up. We will come back to this code later as I show you every one of the steps and what it does. I need to show you the crates that I used to implement this application. There is the Win API, then there is the lib loading crate. This one is for loading the DLL. Then there is the image crate for helping us manage the image, the saving of the image, and the displaying it. And then there is the base64 crate for encoding the bytes that we receive into a base64 encoded string. You know, with a base64 encoded string, you can actually transmit it over a network and even save it to a database if that is what maybe you would like to do. So for the crates, you can see that in the cargo dot, this file here, it is actually this file here, this one here. The major files that I used for this application is the main.rs and the cargo.toml. But I don't understand what toml means. You could share a comment and tell me what toml means. The first time, I'm just going to run the application and not present my finger on the scanner so that I show you what happens if you don't present your finger on the scanner when you run the application. Now to do that, I'm going to minimize the Visual Studio Code IDE so that we can go to the command prompt. Now if you remember earlier on, I had mentioned that we are going to use this toolchain here for building the application and also for running the application. To do that, we are going to run this command, but first let's first clean the application. So I'm going to type cargo space clean. We are going to type cargo. Hey, what am I typing? I'm typing with my left hand. So before I even run that, let me take you first to this text document here so that I can explain things in detail. So I'm going to first clean the application using this command. Then I will then build the application and then run it with this command. So for now we are doing the cargo space clean. So we could even actually by the way, we could first clear this. Should we first clear this so that the CMD is clean? Just do CLS, yeah, like that. Then I just come here to the text document, I select this cargo clean, paste it there, and then I press enter. See what happens. So we have managed to clean our Rust biometric application. Now we need to build it. I will select this code here and copy it. Not code, the command. Sorry, I meant the command. So we are going to run cargo build, and then we target this toolchain here. That is the 32-bit Microsoft toolchain. So to do that, I'm going to press enter. Observe what happens. So it is now building. It is building. The build is still in progress. My build is actually taking a while. Let me know how long it takes you to build your Rust applications. So our build completed, it finished. Now we need to run the application. To run the application, we are going to use this command here, the cargo run, and then we target our 32-bit Microsoft toolchain. The reason why we are using the 32-bit toolchain is because this integration is being done using the ZKTeco Fingerprint DLL, that is also a 32-bit DLL. Let us run this command. So I'm selecting it and doing copy. Then I come back to our command prompt and I paste it there. What did I do? Oh Lord Jesus. Copy. Did I really copy it? Yeah, I've pasted it. Then I just press enter. Observe what happens. So remember I said I won't present my finger during the first instance. I won't present my finger on the scanner during the first instance of running the application. So it has run all the way to completion. As you can see, this step 12 where it says freed up. Oh goodness. Where it says freed up allocated the ZKTeco resources. Now I need to explain this to you. I need to explain to you what happened. So when we run the application using this command here, so it built the application before attempting. It first checked whether anything had changed by building the application. Then it started running the application here. After finishing the build, it started running the application. So this is the headline that I described for my application. I will show you where in the code this bit is featuring. So step 1, what is happening in step 1, because there were, as I mentioned earlier, if you remember, I said that I am using some 12 steps to capture fingerprint, display it, and show the extracted fingerprint template in this Rust biometric application. So in step 1 is where the initialization of the ZKTeco fingerprint API is happening. Then once the initialization is successful, we go to step 2, where we are getting the count of connected ZKTeco devices in the computer. And in that bit, we found that there is one device count. I actually have only one ZKTeco fingerprint scanner, that is a ZKTeco 4500, the one that I am using. So when the application ran, it found that that device was connected to the computer, and that is why we are seeing device count as 1. Now in step 3, we attempt to open that device, and as you can see, the application notified us that this device was successfully opened. Then in step 4, we are getting the width dimension of the open ZKTeco fingerprint device. So different ZKTeco devices will output images of various sizes of width. So since the ZKTeco API is general and it can be used with various other ZKTeco devices, your application needs to determine the width dimension of that particular ZKTeco device that you are using. So in step 4 is where we are getting the width dimension of the open ZKTeco device. And then in step 5 is where we are getting the height dimension of the opened ZKTeco fingerprint device. So you need to determine the width and the height so that you can get the product of the width and height to reserve a memory buffer where the captured fingerprint image bytes will be stored. So you can't be able to just reserve image memory buffer without knowing the width and the height dimension of the device that you are using. So once your connected ZKTeco device is opened, in step 3, you proceed to get the width and the height so that you can use the product of the width and the height to reserve fingerprint image buffer. When we were getting the width, we got 292 pixels. When we were getting the height, we got 374 pixels. So in step 6 is where we are reserving the fingerprint image buffer size using the product of the width and the height. So do your math. What is the product of width and height if your width is 292 and your height is 374? Multiply the two. The product, when I say the product, I mean get 292, get the width multiplied by height, the value of width multiplied by the value of height. Give me that value in the comment section. Now in step 6, that what I've shown you is where we are reserving the fingerprint image buffer size using the product of width and height, that is 292 by 374. Now in step 7 is where we capture the fingerprint image. Now these attempts that you see here, attempt 1, 2, 3, 4 all the way to 10, is the application running every 1 second, checking whether you've placed your finger on the ZKTeco fingerprint scanner. So it does that for like 10 times. And if you don't place a finger on the scanner, don't place your finger on the ZKTeco fingerprint scanner, it shows you this message here: fingerprint not captured after 10 attempts, and then the application exits that loop and proceeds to start closing the ZKTeco fingerprint device in step 11. Also, if suppose you presented your finger on the scanner, the application, once it has captured your fingerprint image, it will proceed to step 11 to close the ZKTeco fingerprint device. But I will show you that one. I will show you that bit in the second instance where I will present my finger on the scanner to show you how the application works when you present your finger on the ZKTeco device. In step 12 is where you free up the allocated ZKTeco resources, and then after that the application comes to an end and it stops. It actually returns you to the next prompt so that you can run it again. So that was the first instance of running the application, and I've been able to show you step 1, step 2, all the way to step 12. But the only thing that I did not do is that I did not present my finger on the scanner. In the next instance, that is the second instance, when I run the application, I am going to present my left index on the scanner so that you can see how the application captures the finger, displays the captured fingerprint image, and also you will also see the fingerprint template that was extracted from the captured fingerprint image. To do that, I need us to first clear the screen. So I'll just type CLS, then I press enter, so that when we get to run the application, you see we have adequate space to see for the output, for us to see. Okay, we needed to do CLS to clear the screen so that when we run the application, we have adequate space for the output from the application. Now let's run the application. I'm going to take you back to this text document here. Then we copy. I'm going to take you back to this text document here. Then we copy this command here for running the application. I have copied it. I have copied it. Jesus, what am I saying? I have copied it. What am I doing? So let me minimize the text document. Then we go back to our command prompt. So I am going to paste that command here. So what we are doing is that we are running the application while targeting the 32-bit toolchain from Microsoft to run our Rust biometric application. Let me press enter, and then when I am prompted to present my finger on the scanner, I will present the left index finger so that the fingerprint image can be captured from it, then it be displayed, and we also be shown the fingerprint template that was extracted from that captured fingerprint image. Let's do this. I'm pressing enter. Now I'm presenting my left index finger on the scanner. I did not present my left index finger on the scanner in good time, so actually the 10 attempts happened before I could present my finger on the scanner. But I will rerun the application again. Let me first do CLS, and then I bring up that run command. Now let me present my finger on the scanner. There goes my captured left index finger. Here it is. Let me first minimize what do I do? Yeah, let us first go to the command prompt so that we see what happened. Then I'll come back to the image. So as you can see, the application concluded at step 12, where it freed up allocated ZKTeco resources. Let's go scroll all the way to the top. So when we run the Rust Biometric application, the application started by first building itself. Then when it finished, it started running the application. So here is where it finished, and then it started running the application. This is the header. I will show you where I have this bit in my code. So this is what defines the application. Then in step 1, the ZKTeco API was initialized, and as you can see, the initialization was successful. Then the application proceeded to step 2 to get the count of connected ZKTeco fingerprint devices, and it got one ZKTeco device, that is the ZKTeco 4500 fingerprint scanner. In step 3, the application opened the ZKTeco device, and you can see that it successfully opened the ZKTeco device. In step 4, the application proceeded to get the width dimension of the open ZKTeco fingerprint device, and we got 292 pixels for the width. In step 5, we proceeded to get the height dimension of the open ZKTeco fingerprint device, and we got 374 pixels for the height. In step 6, the application reserves the fingerprint image buffer it reserves the fingerprint image buffer size, and this size for the fingerprint image buffer is the product of the width 292 and 374. In step 7, the application proceeded to capture fingerprint image. That is when I presented the left index finger on the ZKTeco 4500 fingerprint scanner. So it did several attempts: attempt 1, attempt 2, attempt 3, attempt 4, attempt 5, attempt 6. Then before it hit the 7th attempt, I presented my left index finger on the ZKTeco 4500, and you can see at that time it successfully captured the fingerprint image and also successfully extracted the fingerprint template. In this bit here, you can see that the fingerprint image size is 109208 bytes. Actually, this figure here is the reserved fingerprint image buffer size. It is the product of the width, that is 292, and the height 374 pixels. Confirm whether that is the case and let me know in the comment section. We can also see that the application was able to successfully extract the fingerprint template, and it gave us the size of the template as 1038 bytes. Thereafter, in step 8, the application proceeded to save the captured fingerprint image, and then in step 9, the application opened and displayed the saved fingerprint image. I need to show you what happened in step 8. In step 8, we see that it saved the captured fingerprint image, and we can see that the fingerprint successfully saved to this file here, fingerprint ZKTeco4500.png. Let's go to the application folder and see whether we have any file that looks like this, that is named fingerprint ZKTeco4500.png. Remember, initially we did not have this file in our application sources, but now that we have been able to capture the fingerprint image, we will be able to see a file that is named like this. So I'll come here and look for that file. Here it is, fingerprint ZKTeco4500.png, this one here. So you actually see the time when it was created. Let's do properties. Yeah, you can see that it was created at 7:11:38 p.m. and what is the time now? The time now is 7:18 p.m. So that was 6 minutes ago when this fingerprint image was captured. So I'll just say okay, then let's double click on it to open it. Though you remember the application was able to open, and yeah, here it is. So there are two, because the first one is the one that was opened by the application. This other one is the one that we have opened right now. So here is our captured left index finger. When the application in step 7 proceeded to capture fingerprint image, this is the fingerprint image that was captured from the left index finger. Let me close this. I've been able to show you step 8, where we save the captured fingerprint image. Now we move on to step 9. In step 9 is where the application opened and displayed the saved fingerprint image, and here it is. Remember when the application was running and then it popped up this image? That is what was happening in step 9. In step 10, the application proceeds to display the extracted fingerprint template. This is the template that was extracted from the captured fingerprint image. Could actually call it the hashed code of the captured fingerprint image. At step 10, the bytes of the extracted fingerprint template are encoded, base 64 encoded to a string, and that's why we were able to output this hashed code of the captured fingerprint image here. So this is the base 64 encoded string, or rather the hash code of the captured fingerprint image. In step 11, the device closes. The application closes the ZKTeco device, and we can see that the application actually succeeded to successfully close the ZKTeco device. And then in step 12, the application proceeds to free up allocated ZKTeco resources, and you can see that that is what actually happens in step 12. And then at the very end, the application returns you back to the command prompt. Now I've been able to show you how to capture a fingerprint display the fingerprint and also show you the extracted fingerprint template using the Rust, from our Rust biometric application. What I want to show you now is to take you to the code so that you can see how I was able to implement the various steps from step 1 all the way to step 12. To show you this, I will need to take you back to the Visual Studio Code IDE, and I will need to minimize this bit here. I also need to minimize this other bit here. Then I just open the Visual Studio Code IDE. So I will be alternating between the Visual Studio IDE while showing you the code and taking you back to the command prompt to show you what transpired when we run the application, when we run the particular code that we see from our Visual Studio Code IDE. Now I minimize this, then we go to Visual Studio Code IDE where the Rust biometric application code is running from. Let me take a sip of my beverage here. My tongue is very dry. Now we are in the main.rs file of our Rust biometric application. As I showed you earlier, this is a very short piece of code. It is actually just 343 lines of code. No, 341. So I scroll up to the top. It is only one function. All this piece of code is just running from the main application, the main function. As you can see, I don't have any other functions apart from the main function because this is just a simple demo code for Rust biometric fingerprint capture integration code. But based on your needs, you may decide to break your code into several other functions, but for my case, the main function sufficed for what I needed to show you in this application. These are the imports that I included in the application. These ones here. So if you need to import anything, you just do it from here, and basically this is what I had to import in my application. I needed this for base64 encoding. I needed the discrete I needed discrete for handling the image processing activities, the base64 for encoding the bytes from the fingerprint template, and then this bit for time here so that I could momentarily pause the code. Then there is the Win API. You need this, by the way. There's no way you can do without this. Then the lib loading, create for loading the ZKTeco API, that is the DLL, the library, the dynamic linked library. Okay, back to the main function so that I show you how I was able to pull this off. The first thing I did was to load the library, the ZKTeco Fingerprint API library. If I take you back to my code, my application's sources, you will see this file here. This is the DLL that I am talking about. So this one you will have to get it from the ZKTeco Fingerprint API. If you actually go to the ZKTeco website and download the ZKTeco Fingerprint API, you will find this DLL right there. Once you install your ZKTeco SDK in your Windows computer, you will find this C++ DLL there. One thing before I forget, let me take you back to my web browser here. I need to show you the documentation. Yeah, this is the documentation that ZKTeco will give you for integrating with their ZKTeco API for C. Actually, to be precise, I used the C API in my Rust Biometric application demo to be able to call these functions here for ZKTeco. These ones here from page 5 to page 12. Yeah, to page 12. These are the functions that you need to create function pointers for in your Rust application to be able to interact with your ZKTeco API and make calls to it, so that you can be able to give commands to your ZKTeco fingerprint scanner. Now, let me minimize this so that I take you back to Visual Studio Code. As I had mentioned earlier, the first thing that you need to do is to load the ZKTeco API, and to do that I use the load library crate to load the ZKTeco DLL. Here it is. You can see the path from which I am loading it from. In that in that first line of code in the main function. Now, after we load the library, that is a DLL, we need to create a function pointers for interacting with the ZKTeco API. The first function pointer that I am doing is the one for init, and with our init function pointer we are able to interact with the ZKTeco init function. Let me take you to the ZKTeco API document guide so that I can show you the ZKTeco init function. From our web browser here, inside our ZKTeco API document, I will click on this bit here. So this is how the ZKTeco init function looks like. This is how it is defined. As you can see, it doesn't take any argument, but then it does return a 0 if it is successful, and it will show you other numbers if it is not successful. Actually, for the errors that you will receive, let me take you to the appendix here so that you can see what other values you could get. So in this appendix, if you get a 0, you know that the operation was successful. If you get any other values, you know that it was not successful, apart from 1, that is if it successfully initialized. So for 0, you know that your operation was successful. For 1, you know that your ZKTeco init function was successfully initialized. So let me take you back to the ZKTeco init function. I'm scrolling all the way to the top. But then, do I need to make this document to show a bigger font? I think that one is much better. Okay, where is our ZKTeco in it? And here it is. Excuse me. Let me take you back to Visual Studio Code. So I've been able to show you the function for initializing ZKTeco. Let me show you the function for getting the count of connected ZKTeco devices, this one here. So here I am defining this function pointer red count that will bind to the get device count, the ZKTeco device count, this one here. So if I could quickly dash to the ZKTeco API document, you will see this ZKTeco device count function. This is how it is defined. If the device count found a ZKTeco device connected to the computer, it will show you a value that is greater than 0. That is 1, 2, 3, 4, depending on the number of ZKTeco devices that you have on your computer. If you have 1, it will just return a 1. Now let me take you back to the Visual Studio Code to show you the next function. The next function is for opening ZKTeco device, and in this function we are having open device function pointer that is binding to the ZKTeco open device. Let me take you to the ZKTeco API documentation so that you can see the open device function, how it is implemented in the C API. Here it is. So this one takes an argument that is the index. So the index, suppose you have one ZKTeco. Okay, let me first start by saying, once your ZKTeco API determines that during the ZKTeco device count, it determines that there is a device. It puts, or there are devices, it puts them in a list. And as you know, in the programming, the list starts at 0. So if you have one device and the ZKTeco API was able to return 1 after ZKTeco device, it will mean in the list for the connected ZKTeco devices, it will that one device that is connected will be represented by index 0. So if you have one device, you will just pass 0 for index in the ZKTeco open device function. Now if you have, let's say, like 2 devices that are connected to your computer, that is ZKTeco devices, the first device will be given an index 0 and the second device will be given an index 1. So if you want to use the first device in your ZKTeco open device function, you will use index 0. If you want to use the second device in your ZKTeco open device, you will use index S1. 1 minute please. So that's it for ZKTeco open device function. Let's go back to our Visual Studio Code. I show you the next function, implementation. Now in the next function, we are getting parameters, and to get our parameters we are using this function pointer that we define get params, and we are binding it to ZKTeco get parameters. Let me take you to the ZKTeco API documentation to show you that bit. Here is the ZKTeco get parameters C function. Now what happens in the ZKTeco get parameters function? The get parameters ZKTeco function is what is going to give us the width, the height, and the DPI of the particular ZKTeco device that we are using. Now, to be able to get those three items, whether it is the width, whether it is the height, or the DPI, we need to pass the device handle to ZKTeco get parameters function, and we also need to pass something we are calling the param code, that is the parameter code, and the param value and the size of the param value. One thing I forgot to mention is that during ZKTeco open device, once we pass the device that we want to use, we receive a device handle. A device handle is like a pointer to the hardware, that is the ZKTeco device that we are using. So your computer, your program needs to know which device it is going to use to be able to carry out further operations like the fingerprint capture and the template extraction from that fingerprint that was captured using that device. So to be able to narrow down to a particular device that you want to use, you need its device handle, like a pointer to that device. So in our get parameters function, we need to pass the device handle that we got from open device. We also need to pass the param code. Now let me explain the param code. The param code, actually the param code is just an integer. If your param code is 1, you know that you are seeking to get the width. If your param code is 2, you are seeking to get the height. If your param code is 3, you are seeking to get the DPI, that is the image resolution. I will show you that bit when I'm showing you the code for getting width and getting height. Now the other function is acquire fingerprint. The acquire fingerprint function pointer that binds to the ZKTeco acquire fingerprint here. Now if I take you to the ZKTeco API document, I'll show you, you'll be able to see the acquire fingerprint ZKTeco function here in C, how it is defined. This is how it looks like. So once it runs successfully, it will give us it will return a fingerprint image, and it will return the fingerprint template. So not only will it return the fingerprint image, but also give us the size of the fingerprint image bytes. And not only will it give us the fingerprint template, but also give us the size of the fingerprint template bytes. That is why in our command prompt you could see this during fingerprint capture. You could see this here, fingerprint image size bytes and the fingerprint template bytes. Now let me take you back to the Visual Studio Code IDE so that we explore. It's like we have gone through all the functions that we are using. Is there any other one that is, yeah, there's these other ones here. There are only 2 remaining. So there is this one, this close function, this close device function pointer that is binding to close device ZKTeco function. Okay, if we go back to our ZKTeco API document, you will see this close device. Where is it? I think I saw it. Yeah, here it is. So it is binding to this ZKTeco close device function. This is the one that in C it closes the ZKTeco device that we had opened. Let's go back to Visual Studio Code again. Now, our last function pointer here is the terminate function pointer. It binds to the ZKTeco terminate function in C. Let me take you back to the ZKTeco API documentation to show you the terminate ZKTeco function. Here it is. So this one here is the definition for the ZKTeco terminate function. It frees up the allocated ZKTeco resources once the application is done with any operations that you are doing with your connected ZKTeco device. Okay, back to Visual Studio Code. Now, once I am through with the application now, from this bit here, I'm showing you how we create the function pointers to the ZKTeco API C functions. Then once the application is done with that, it then runs this bit here. It prints the title, rather what the application is doing, that is Rust Biometric integration using ZKTeco 4500 finger scanner, and that is the bit that you are seeing here. Okay, now I go back to Visual Studio Code. Now in step 1 we do the initialization of the ZKTeco API, and here we call this function, and then we expect an int value from it. So if the int value is 0, this one here, we know that it was successful. So this is our function pointer here. You can remember this one here to the ZKTeco init function. So once this bit is successful, the initialization is successful, you will see initialization successful. Otherwise, if it returned any other value that is not a 0, you will see initialization failed. So if you go back to the command prompt, you will see that it gave us this output here, initialization successful for step 1. Let's quickly go to step 2. In step 2 is where we are getting count of ZKTeco fingerprint devices. So what is happening in step 2? We are calling the get count function, and then we are getting its int value in dev count. If let me first show you the get count here. Here is our get count function pointer that is calling the get device count from ZKTeco C API. So if our get count, where is our get count in step 2? Yeah, once it runs, it returns an int value in dev count variable, and if dev count is greater than 1, we don't intend to use, in this application we do not intend to use more than one device. So we just want to make sure the application is only using one ZKTeco device at a time. So that's why I am doing this return here. Otherwise, if dev count is 0, it means that there was no ZKTeco device that was found, and we proceed to do a return. The ideal situation is that we have one ZKTeco device, and once we have one ZKTeco device, we proceed on to step 3. So our application found one, and it returned this message here, ZKTeco fingerprint device found. Let me show you that bit in the command prompt here. This bit here, one ZKTeco fingerprint device found. Application will now attempt to open it. So that is from this bit here. This bit here. I noticed one thing when I was doing this integration. If you immediately proceed to open the ZKTeco device that you want to use, immediately after getting dev count, the application will return what error was that? Was it an access violation error? So I discovered the best way was to first put the application on sleep for 1 second, that is 1000 milliseconds, before proceeding to open the ZKTeco device. So in step 3 is where we are doing open ZKTeco device, and in this step we are using index 0. Remember, we said we only want to use one device at a time. So if it is one device, that device, assuming it is the one that is in the list for dev count, it is going to be index 0. So I declared this variable here, dev index, and it is the one that I am going to pass in open device count in step 3. So our open device function here is receiving our dev index as 0, and then it returns a handle. So if our device handle is null, the application will complain that ZKTeco fingerprint device failed to open. If there is if our device handle was not a null, I will proceed to show the user that the ZKTeco fingerprint device is successfully opened. In our command prompt, you can see this bit here in step 3, where we are attempting to open the ZKTeco device, and then I show the user ZKTeco fingerprint device is successfully open. So that means our device handle is not null, because we successfully managed to open the only ZKTeco device at index 0 that is connected to this computer. Okay, so our open device function here, the one that we came up with here, is binding to our ZKTeco open device to get the device handle. Now let's move to step 4. So in our step 4 is where we are getting the width. So to get the width, we need to call the function the get params. Remember the get params function, the one that was binding to, let me show you here, this one here, that is binding to the ZKTeco get parameters function. In step 4 here. So here it is. Now we are attempting to get the width. So to get the width, we need to pass the device handle. We also need to pass the param code S3, that is why we are calling param code width. So I defined these param codes here. So for param code width, that is 1, is going to give us the width. If param code is 2, it is going to give us the height. If the param code is 3, it is going to give us the DPI for the image resolution. So in our case, when we are getting the width, we are passing this int variable here. Param code, this value 1, we are passing param code width, and for the height we will be passing param code height, and we won't be doing the one for DPI. So in step 4, let's go back to step 4 where we're getting the width. I clarify these things for you. So we pass the device handle. You remember you got the device handle from the open device function, then the param code width, this one is 1. A minute please. And then we receive the finger image buffer. These bytes we will decode them to an int. We'll decode them to an int so that we can get the width. And then this bit here is the size of the finger image buffer. So this will be the size of the bytes that we are getting here, and once we get these bytes here, we decode them to an int to get the pixel value for width. Similarly, for step 5, when you're getting the height, we will also pass the same. We will pass the param code as param code height, which is value 2. Then we will get this. We will get the bytes output here that we'll need to decode to an int so as to get the pixels for the height. And this is the size of this buffer here. It is actually 4, by the way. It is actually 4. I hope you can see this 4 here. Now, in our width, when we run this get parameters function, if res width is equals 0, that is the output from the get parameters here for width, we know it has successfully managed to get the width. And we have this variable here, that is fp image width, that we are decoding the bytes to int after we pass it to this function here. So our variable here, this one here, these bytes here, we pass them into this Rust function here so that we can get the int value equivalent for the width. And once we get it, we print width as this int value here. And from our command prompt, you can see this is what we are getting. This is the int value we are getting here for pixels, that is 292 pixels. Let me take you to step 5. By the way, these two are intertwined because they're all calling the same function. The only difference is what we are passing for param code. For width, we are passing the param code as 1, whilst for the height, we are passing the param code as 2. Let me take you to step 5. So in step 5, for get width, this res height here is what we are getting after calling our get params and passing the param code as 3. If I place my cursor here, it doesn't behave like okay, let me see. Anyway, the param code height here, this one here, where is it? It is 2. This one here, 2. So once we pass param code as 2, that is param code height is equals 2, we will get the bytes that represent the height in this variable here, in this pointer variable here. And then these bytes here, we will need to decode them to an int. You can see here, we'll need to decode them to an int so that we can get our fp image height value. Now once we have managed to decode them to an int, we then proceed to do this print here, and you will see that from our command prompt we get that height is 374. Back to Visual Studio Code. Oh, I'm losing my voice. I need to sip something here. Okay, so I've been able to show you what is happening in step 4 and what is happening in step 5. In step 4 is where we are getting the width, and in step 5 is where we are getting the height. Now in step 6, actually in this bit of code here, this is if I wanted to show you, if I wanted to output the DPI, I will comment out this code so that I can pass the param code. I will still call the get parameters, but then I pass the param code S3. So to pass the param code S3, I will use the variable param code underscore DPI, which is actually 3 from here. You can see here it is 3. Let's move to step. We need to move to step. Step what? Yeah, we need to move to step 6. In step 6 is where we are reserving fingerprint image buffer, and to do that we need to get product of the width and the height. So I'm declaring this variable here, the FP image size, and then I do the image width. Remember, this one was assigned integer from here. Where is it? You can see it is assigned integer I32, but then it needs to be an unsigned integer, so that's why I'm doing as unsigned integer, because we are working with bytes. So FP image size here is an unsigned integer. Because our FP image width is assigned integer, it's like we do a cast type. So we cast type it to an unsigned integer, that is U32. So U32, why U32, why I32? This is because this is for a 32-bit application. We are using the toolchain for 32-bit, and also remember that I also mentioned earlier that our ZKTeco DLL is a 32-bit library. Otherwise, if you are using a 64-bit machine and you have a 64-bit ZKTeco library, you wouldn't be using U32 or I32 for unsigned integer and signed integer. You will be using U64. So this is the product that we are, this is the image size that is going to be the product of our image width and our image height. So for both the width and the height, we need to cast type them to unsigned integer. That is why we are doing as U32s, U32 for the height and for the width. Now with our with our FP image size known, we also need to determine the template size. So the template size in the documentation, you see that there's somewhere where they said it is usually 2048. I'm trying to trace it. Yeah, so the max is 2048. Pre-allocated memory size of the fingerprint template, it is recommended that it be set to maximum template size, which is 2048, though it will be lesser than that. But then in the documentation, ZKTeco tells you to use this value, so you'll be able to reserve 2048 size of bytes in your memory. But once your fingerprint is captured and extracted and the fingerprint template is extracted, you will find that it is a different value, actually lower than 2048. But then 2048 is what you use to reserve memory for storing the extracted fingerprint template in your application. And I need to show you that bit in the code, in the command prompt. Yeah, in our command prompt here, when the fingerprint template was captured, you will see that the application told us the fingerprint template size is 1038 bytes. It usually varies, but it won't be more than 2048. So for our left index, it shows that the template that was extracted from the captured fingerprint image was 1038 bytes, but from our ZKTeco API documentation, you can see that it reserves a max of 2048, which is much more than what your extracted fingerprint template is actually, the size of your extracted fingerprint template is going to be. Okay, that was step 8, where we are reserving memory for the fingerprint image size and for the template size. So for the fingerprint image you need to compute it, but for the template you just use 2048, but then the application will tell you the exact template size once the fingerprint image has been captured and the template has been extracted. So these are the other variables that we are going to use. This is where we are going to archive our image buffer, and this is where we are going to archive our template buffer, and this is the actual template size, the one that you see as show here. Okay, 1 minute please, someone is calling me. Sorry for that. Let us continue. Now this is the variable for the attempts that I will make during the fingerprint capture, that is max attempts 10. The retry, the times that I'm retrying, if during that attempt, okay, maybe I need to show you what are those attempts that I am talking about. You see these ones here, this is what I'm calling the attempts. So the first attempt, the second attempt, the third attempt, the fourth, the fifth, and the sixth. So they run all the way to 10. So if before the 10th one you would not have placed your finger on the scanner, the application will just will just stop. But in between is where you should place your finger on the scanner, as the application retries to scan the finger scanner every 1 second. So during the demo, you can see that after the 6th attempt, I placed my finger on the scanner just before the application did the 7th attempt. Back to Visual Studio Code again. Okay, now let's go to step 7. I show you how I'm capturing the fingerprint image. So this is the code for capturing the fingerprint image. So I'm retrying the attempts inside a while loop. So while attempts are less than max attempts, which is 10, and as long as our boolean variable captured is not true, the application proceeds to the next attempt. But the moment captured boolean variable is true, this one here, the moment it is true, it will stop, because it will mean that the fingerprint has been captured, and then it will save the fingerprint image and display it and extract the fingerprint template. So that bit is happening here in this function here. where we call the acquire fingerprint function. So in our acquire fingerprint function, we are passing the what am I doing? In the acquire fingerprint function, we are passing the device handle, we are passing the image buffer where the image is going to be saved, the bytes for the image of the captured image, and the FP image size, that is the size of this image buffer. FP image size is the size of the bytes here, and then the template buffer for the extracted fingerprint template is going to be saved here, and this is its actual size. So once our acquire fingerprint function runs, it returns an int value in our res capture here, this variable here. Our acquire fingerprint, let me first take you to the acquire fingerprint to show you what function it is binding to on the ZKTeco C API. Where is it? There, here it is. So our function pointer, the acquire fingerprint here, is binding to the ZKTeco acquire fingerprint C API function. Let's go back to step 7 again, show you the acquire fingerprint, what it is doing. So I've been able to show you what we need to pass into our acquire fingerprint: the device handle, the image buffer size, the template buffer, and then this is actually a pointer, by the way, and this is also a pointer to the memory where the API is outputting the captured fingerprint template, and a pointer to the memory where the API is outputting the captured fingerprint image here. So if res capture, the output from the acquire fingerprint here is 0, we know it is successful. Let me show you in the ZKTeco API here. Where is it? Here. This is our the ZKTeco acquire fingerprint function, and we see from the documentation that if it is 0, it means that it was successful. Sorry about that. So if it is 0, we output this. We show that the fingerprint image capture was successful. We also show that the fingerprint template extracted was successful, and we also show the size of the fingerprint image size in bytes, and we also show the fingerprint template size in bytes. So for this 4 lines of code here, let me show you how what we received from in our command prompt when we run the application. So that happened after the capture. So here they are. So we get fingerprint image capture success, fingerprint template extracted success, then we get the bytes for the fingerprint image, and we get the bytes size for the fingerprint template. Now let's go back to Visual Studio Code, but we are almost winding up. This is just the last bit. So once we have the fingerprint image successfully captured, we create the image using the bytes. So this is what this code is doing here. And then in step 8, we save the captured fingerprint image. So once this code runs successfully, you will see the fingerprint successfully saved to this file here, fingerprint _ ZKTeco4500.png. So in our command prompt, you will see this line here, this output here. In step 8, fingerprint successfully saved to this file here, and from our project sources, this is the file that was saved. The fingerprint image file saved as a PNG file. Let's move on to step 9. I've been able to show you step 8 where we are saving the fingerprint image. Now in step 9 is where we open and display the saved fingerprint image, and this is the code that is actually doing that. This code here is actually doing that. Then in step 10 we display the extracted fingerprint template. So from our command prompt here, once this is successfully done, you will see step 10 display extracted the fingerprint template. So before I even show you the command prompt, I need to show you what is happening. So the template buffer, the pointer to the bytes in memory for the extracted fingerprint template, is first passed through this base64 function here. Remember from our base64 crate, the one that I showed you here, this one here. So it has this function here called encode. So the encode function is going to receive as a value the template buffer, an array that is of bytes, then it encodes them into a string. So once it encodes them to a string, it will output them, and this print function here is the one that is printing the template, the encoded base64 template buffer as a string. So here it is, the hash code that you see there for the fingerprint image is this one here. It is what we are calling the fingerprint template. Now let's move to step 11. So if the fingerprint image failed, that is if we received a -8, that is the error for when the fingerprint failed to capture. The application retries the fingerprint capture again. So that is why you see I pause for 1 second, and then the application retries again because captured is not equals to true, it is still false. Remember our captured here. Where is our captured? Our captured here. You remember our captured here. As long as it is false, the application continues to run acquire fingerprint again, this function here, until captured is returned as true, and that is done for 10 times. This one here, as long as max attempts has not yet reached 10. So I've been able to show you how fingerprint capture is happening in step 7, how we are saving the fingerprint image in step 8, and how we are opening the captured fingerprint image in step 9, and in step 10 where we are displaying the extracted fingerprint template after encoding it to a base64 string. Once we are done with fingerprint capture, we need to close the device and terminate the ZKTeco resources before the application runs, before the application stops. So to do that, in step 11 is where we are closing the ZKTeco device, and to do that we are calling this function here and getting the output in the rest close variable. So if rest close is equals to rest, in other words, I mean the result is the result from close. That is what I mean with this variable here. If the result close variable is 0, we know that ZKTeco device successfully closed. And from our command prompt here, when we are running the application, you can see that in step 11 here, where we are closing the ZKTeco device, the application was able to output this ZKTeco fingerprint device successfully closed. That line was printed by this bit of code here, this one here, this bit here. Then once we close the ZKTeco device, in step 12 we need to free up the ZKTeco resources that we assigned during step 1 when we were initializing the ZKTeco API. So to do that, we call the terminate function. Remember our terminate function? We call the terminate function here. Let me take you to the terminate function here. The way to the top. Where is our terminate function? Yeah, this is our terminate function pointer that is binding to our terminate ZKTeco C function. Let me take you to the C API guide so that I can show you the terminate. Where is our terminate? Yeah, here it is. So if it returns as 0, we know that it successfully managed to terminate the ZKTeco API resources that were allocated to the application. So let me scroll down to our terminate in step 12. So once that is done, we receive this message here, freed up allocated ZKTeco resources. And you can see from the command prompt here, when we are doing step 12, that is free up allocated ZKTeco resources, and we receive this message here, freed up allocated ZKTeco resources from this bit here. Then I print this line here, you can see it here, here it is. And then after that, there's something I need to show you. I realized that if I don't call this process.exit and pass at 0, I will receive an access violation error. I don't even know how I figured out that. Oh yeah, I remember. Yeah, I looked up this on internet. Then somewhere I found that this is happening because the application is trying to do a double drop, like trying to do termination twice for the device that is the one. This is the one that is being done by the API, and then the application itself is also attempting to terminate the resources that it was using. So it does it like twice, this one and the application itself. The way it works, it tries to free the allocated the ZKTeco allocated resources, but then by that time this function will have already run. So to prevent that error, to prevent the access violation error, because why it is returning the access violations, because it is trying to free up the resources, but then the ZKTeco resources have already been freed by the ZKTeco terminate function. So This was the remedy to prevent, I used to prevent the double drop. So I decided to use this to gracefully close the Rust biometric application. So I call the process.exit and then I pass 0, and once the application meets this line of code, it terminates gracefully. And that is why after terminate, you see from the command prompt the application returning us to the prompt, to the command prompt, so that we can run the application again if we wish to. So basically that's it. That's how I ended up implementing this Rust biometric application for fingerprint capture and fingerprint template extraction using the ZKTeco ZK4500 fingerprint scanner. So this brings us to an end for this demo. Thank you for watching all the way to the end. Let me know if you have any questions. Drop down any comments that you may have in regards to how I did this integration, and if you need any help in regards to doing your Rust integration using any biometric device, feel free to reach out. You can see my contacts in the description or in the pinned comment. You can actually visit my official website or my blog. You will see the details in either the description of this video or in the pinned comment, where you can find contacts to reach me. Otherwise, thank you so much. Thank you for watching this video all the way to the end. See you in the next one.